You're totally using ClaudeCode wrong, and it's not your fault. In fact, 90% of developers waste thousands of tokens every single day without realizing it. But today, I'm going to show you 3 context engineering tricks that will make ClaudeCode feel like an elite coding partner instead of a confused intern. So in this video, I'll show you 3 main strategies that will make a great impact on your coding experience with ClaudeCode. These are context trimming, subagents, and parallelism. First, let's talk about context trimming. So context trimming is all about making your coding experience more efficient by clearing up unnecessary information in your context window, or making your coding experience faster by reducing your unnecessary or redundant prompting. And it's also about using external tools that will make your memory more efficient. So the first trick in context trimming is reducing your cloud.md files. As you know that ClaudeCode has its own memory system, which lives inside cloud.md files, but sometimes these files can be overwhelmingly large and take a really huge space in your context window. When you start a new section, it will tell you that the cloud.md files are too big and it's taking too much space in your context window. So as you can see here, my cloud.md file has over 3,000 lines, which is a bit of an exaggeration, but you get the point. It just means that when you have too many projects, or when your project grows too big, the memory inside of cloud.md will be really huge as well. And to make it more and to make it clearer, when I hit /context, I can see that my memory files takes over 26K tokens, which is over 13% of the entire context window. So, and when you start a new section, 13% of the context window is already gone by these memory files, which is very inefficient. Shrinking is all about making your cloud.md files as concise as possible. You just want to add the most important critical information inside of these files for your project. So for example, in my project, I just want to add the instructions on how to use Byterover tools inside of the cloud.md file. I don't want to add anything else because it's going to overwhelm my context window. So now if I start a new section, you see that the warning before has already gone because I clear up my cloud.md file, and when I hit /context, the memory file only takes up 0.6% of the entire context window, which is pretty efficient. The second trick in context trimming is context initialization. So context trimming is not only about using as less token as possible, it's also about making your coding experience faster and more time efficient. So when you code with ClaudeCode, you probably spend most of the time prompting or giving instruction to your ClaudeCode because you want to make sure that your agent understands what you're trying to do. ClaudeCode has a very niche feature for these redundant tasks, which is custom /commands. So as you can see here in my .claude folder, I have 2 custom commands, which is initialize bug and initialize feature. I use the command lines when I encounter a bug and I want ClaudeCode to resolve it for me. So I give very basic and very fundamental instruction for ClaudeCode. And maybe when I want to start a new feature, I also give a basic and fundamental prompt for the agent. So why do we use the command lines? Because most of the time when you code with agents, you don't want to spend too much time prompting, giving instructions. So these custom command lines really help you reduce those redundant and repeated tasks. So as you can see here on the screen, I am using the /initialize bug command and followed by, like a GitHub issue. So to give you more context, I'm currently working on my open source project, which is Cypher, and there is a bug that is reported by our community. So I'm just using the initialize bug /command and followed by the GitHub issue link. ClaudeCode is going to do the rest for us because we already give it a prompt template on how to resolve GitHub issues or resolve bugs. You no longer have to do a lot of prompting or instruction guiding for your agent. You just need to craft these /commands and reuse them over time. So the final trick that I want to introduce with context trimming is memory tools. As we know that ClaudeCode has its own inherent memory system, which lives inside of cloud.md files. But as I said earlier, these are really critical limitations with these memory files because it's going to be inside of your context window or your section all the time. Doesn't matter if you want it or not. So we can use memory tools like Byterover to dynamically retrieve and store necessary information only. As you can see here, ClaudeCode is still trying to resolve the GitHub issue that I gave it earlier, but it uses our MCP server tool to get the best context, the most relevant context inside of the memory store. So why these memory tools are more efficient than cloud.md files? The reason is pretty simple. Cloud.md files will be added inside the context window all the time. It doesn't matter if you want it or not, but these memory tools will retrieve only the necessary and the relevant memories to your ClaudeCode. So even though that we have successfully completed the fix, you can see that when I hit /context, it is still over 30% of the context window, and the memory file is only 0.6%. So it's very efficient. You don't overwhelm your context window with a lot of memories. Only necessary memories are added. So that's context trimming. Now let's talk about subagents. So ClaudeCode is one of pioneer in implementing subagents. So it just means that when you're using ClaudeCode, you are interacting with the main agent, and this agent can delegate tasks to other agents to do things for it. So why is it important? Because the main agent's context window is limited. You don't want to tell it to do all the tasks. You want the main agent to do the most important tasks only. So maybe less significant tasks like doing web search or investigate errors can be handed over to subagents that are more specifically designed for these tasks. So as you can see here, I have three main subagents in ClaudeCode. The one subagent investigates errors in my project, one subagent does web search, and the final subagent calls multiple MCP server tools. So when you hit /context, you can see that these subagents only take up a really small percentage of the context window, which is all about 116 tokens, which is very efficient. Because when you use subagents, we delegate tasks for other agents rather than our primary agent. So we don't overwhelm our context window with less significant tasks, because these tasks are already handled by our subagents. And so every subagent is a fork of the main agent. So it has its own tools, it has its own context window. So the main agent context window is retained. It only adds important information for your task. Other unimportant tasks already handled by the subagents. To use these subagents, it's very simple. Just ask ClaudeCode or our main agent to delegate tasks to these subagents. So again, I have one more GitHub issue, which is like a feature request from our community, and I can tell agent to research about this feature request. You can see here our main agent has delegated the task of researching the feature request for the web search agent. What it does under the hood is that the task has already handled by the subagent, so the context window or like the context of the main agent is reserved. Now our main agent is just waiting for the web search agent to complete its task and move on to the next phase. On the other hand, our main agent does not have to waste its tokens or waste the context window for this task, because it's pretty insignificant and it can handle successfully by another agent. Web search agent has successfully done its research about the feature request, and now when I hit /context, you can see that the context of our main agent has been successfully preserved. We still have over 66% of the entire context window, because all the heavy lifting of researching and web searching is done by the subagent, not the main agent. So you can go on and spend the remaining 132k tokens for other tasks that are more important for your primary agent, or maybe you can use other subagents to do other less important tasks one more time, and then your main agent is the one that unify or concatenates all of the work from your subagents. Let me talk a little bit about the format of these subagents. So again, subagents are just prompts. These are forks of the main agents that do very specific tasks. So like for example, our web search agent, first of all, we have the role and like identity of the agent. You want right here, you want to specify what the agent does, and like what tools and capabilities are available to the agent. You also want to specify the objective of the agent. So in the methodology, what ways you want the agent to work to complete the task. What are the quality standards that are considered in completing these tasks. So it is a very structured and comprehensive format that I always use for my subagents. Other subagents like MCP tool calling also have this format. And again, with the error investigation agent, it also follows this format. Finally, let's talk about parallelism. So we enter the realm of multi-agent workflow now. So how is it different from our main agent and subagents that I discussed earlier? So as you can see that with parallelism, we have background agents working simultaneously with the main agent. It means that your main agent do not have to wait for other subagents to complete a task and hand over the results to the main agent. With parallelism, we have background agents working in the background, and your main agent can do other tasks in the same time. So again, the main difference between subagents and parallelism is that, with subagents, your main agent has to wait for other agents to complete its tasks so that maybe it can continue with its workflow. But with parallelism, your main agent continue working on its task while other background agents working on its own tasks simultaneously. So the simplest form of parallelism or a multi-agent platform is through our / command. So as you can see here, I have the background markdown file inside of my commands folder. So it's another custom command that I have for ClaudeCode, but this one is a little bit different. So inside of this command, I am instructing ClaudeCode to, initiate an instance of ClaudeCode within itself. So as you can see here, I'm asking it to start a new ClaudeCode instance and do its own tasks. And I also tell ClaudeCode to, make a report file or like a log file when it does its job, because, it is working in the background. So maybe I want to make sure that it is on the same track. It is on the task that I'm giving it. So I'm telling the agent to, make a log file or like a report file so that I have like a better understanding of what it is trying to do. So to see it in action, I'm going to tell ClaudeCode to use a background command. And inside of this background command, I also use the initialize feature that we've just talked earlier. It's in here. It is the initialize feature / command that I introduced in the first strategy. When I hit enter, and what it does under the hood is that ClaudeCode will initiate a new ClaudeCode instance in the background, and it will do this task while the main agent it can do other tasks. So as you can see here, there is one background task that is currently running inside of my ClaudeCode, and when you hit the / background command, you can see that when you use the custom / command, it will fire off a full ClaudeCode instance in the background for you. Besides working in the background, I also tell my agents to make a report file so that I can have a better understanding about what ClaudeCode is trying to do. And inside of agents folder, you can see here, there is one report file for my background task. To give you guys some update, beside the main report file, it also creates another file detailing all of the changes it made in my source code. So I think it's almost done now. I just need to wait for maybe a few minutes to let it finalize the final steps. Okay, it's done now. As you can see that, beside our 2 report files, it also gives us like a, example file how to use or how to test this feature. And to make sure that the context of our main agent is always clean, you can check in the / context command. And as you can see here, we have over 100K token left, which is like a fresh new section because, the background agents are working simultaneously in the background. It does not affect the main agent context window. Those are the 3 main advanced context engineering strategies that separate average ClaudeCode user from actual AI engineers. If you think this video is helpful, please tell us which strategy that you're going to use first. Also, check out this video if you want to find out more about an alternative memory management system rather than Cloud.md. Thanks for watching this video. Please try out our strategies and tell us how it worked for you guys.